Hello and welcome back to Invitation to Puzzles, where today we have a Kropki arrow puzzle by FullDeck and missing a few cards. I am still, by the way, soliciting a collective noun for the two of them together, since despite the thematic resemblance, there's no word in common, so calling them the cards or the decks both feel slightly awkward. So if you have a good collective noun for the two of them, I would appreciate it. But let's get into the rules for this puzzle. So we have some arrows. So the digit in the circle is the sum of the digits along the arrow. So for example, I could make this a 5 with a 1 and a 4. That would be a perfectly valid way to fill this out. And then I could make this a 7, except I can't, but we could pretend. We could make this a 9 with a 2 and a 7, that kind of thing. That is those. And then we also have Kropki pairs. So these white dot digits are consecutive. So they could be, and I don't know why, but I always say 6 and 7 in some order. So they could be 6 and 7 or 7 and 6, either way. And the black dot, for some reason, I mix up. It can either be like 2 and 4 or 8 and 4. They need to have, one needs to be double the other. And it's worth noting the only valid options in a 9x9 Sudoku are 1, 2, 4, 8 and 3, 6. So the black dot actually doesn't have that many combinations that are eligible to be used, although it does cover 6 different digits. So it's not like you can just center mark them all to start. I mean, you could, but I don't just center mark them all to start. I would not recommend. Alrighty, though. That's the rules. There's a link in the description. So I'm going to go ahead and solve it. But if you want to solve it before you watch me solve it, by all means, please do. Feel free to leave me on mute in the background so I get all the views, because, we're here for the views. Wahaha. All right, so I realize there's only one black dot in the grid, but it's kind of an interesting black dot because of the secret with arrows, which is arrows don't have that many standard tricks. There's a lot you can do with arrows, but there's one standard arrow trick that you see all the time in 2+ star arrow puzzles, which is this one. Which is, you might think that little stubby arrows like this that are only too long are useless, because I could make this a 3 with a 2 and a 1. And well, that's not very big. However, this length 2 arrow, I actually have to make this at least 6, which is quite a bit bigger than 3. It's in fact twice as big. I will leave to you as an exercise. But the way that this works, actually, the reason why it works this way, is because of the fact that these 2 arrows share a column. And so actually the yellow cells that I've highlighted, if I consider them together, their minimum is 1, 2, 3, 4, 5, aka 15, which means that the circles, which have to have the same sum because it's counting the same cells, those have to add to at least 15. But since the largest digit you could put in one of the circles is a 9, the smallest number you can put in the other circle is a 6. And so actually right away, these are 6, 7, 8, 9. But owing to the fact that this digit is on a black dot, it's certainly not 7 or 9. Oops. Because if this were 7, I would need a 14 or a 3.5 here, which would both be problematic. And likewise, if this were 9. Okay, and so now, just based on that, I actually now know this digit's not a 6. Because if this digit were to be a 6, then we would have the problem that these two would now add to 14, which is not at least 15, fun fact. So this is certainly a 7, 8, or 9. And 6 and 8, they go with 3, 4, depending. Now, I feel like 8, 4, 7, 1, 2, 3, 5 is a valid combination as best I can tell. At least until I think about more things. I maybe should, before I think too much about other things, note also that I have this repeated pattern around the grid where these all have to be 6, 7, 8, 9 just by virtue of the fact that they're length 3 arrows with no repeated digits. So this digit's also like 5, 6, 7, 8, 9 because it's consecutive with a 6, 7, 8, 9. And I can repeat the 15 trick actually all the way around the grid as well, although it's less exciting because there's not a black dot there. But this and this also have to be from 6, 7, 8, 9, and that has to be from 6, 7, 8, 9 by considering in turn those 5 cells and these 5 cells and these 5 cells. Okay, now very annoyingly, I can put a 6, 7, 8, 9 in these cells, which is somewhat irksome to me. Let's see, what am I doing now? We've got all the, this is also a 5, 6, 7, 8, 9. This white dot is very interesting. I wonder if I'm trying to make some sort of like, I almost don't want to even say this out loud, but I'm wondering if this is like some sort of finned X-wing on 9s, because you certainly can't put a 9 anywhere along these arrows, or finned swordfish or something, because like the only places in this row, for example, that can be 9 are those, and the only places in this row that can be 9 are those, which is like very close. Oh, in fact, actually, okay, so this is slightly better and slightly worse in some ways. That can't actually be a 9 for the somewhat hilarious reason that if this was a 9, then this cell would be an 8, and this arrow would have to sum to 9, and ditto that one. So actually this, in some ways, looks more promising, although we've got some slight issues that this actually kind of wants to be a swordfish on 9s, which it's not. Oh no, this is just an X-wing on 9s and columns 1 and 9 instead of rows 1 and 9. Okay, okay, let's oh, it's not quite, is it? Okay, well we're if I do the same thing where I highlight the cells in this column that can be 9, that is not one of them, because again, that would make this an 8, and that would be catastrophic. And this one isn't either. So these are the only cells in column 1 that can be 9. Unfortunately, in column 9, we almost but not quite get that. But this could be 9. This column I don't really know much about. So, unfortunately, the aforementioned finned X-wing thing, I think, doesn't do anything. Okay, what else can I contemplate here if that's not what I'm doing? Oh, there's definitely a thing with parity happening. That's almost worth considering. Not quite. The white dots are not well positioned for me to make a parity argument, I don't think. I guess maybe the question I'm supposed to ask is, what's the minimum this digit can be? Because these sum to a maximum of double 8, 9, right? If this is an 8 and this is a 9, then these sum to 17 plus another 17 is 34, and these two still need to add to at least 11, which I guess gives me the all-powerful deduction that this number is at least 2, which doesn't feel prodigious, as Simon would say. Now, I actually can prove separately that this digit can't be a 1, 2, or 3, at least. Because I need to use all the 1, 2, 3s in my sum to at most 17. I do keep asking myself where the last 6, 7, 8, 9 in one of these rows and columns is, but I don't think it tells me anything right away. And like counting 1, 2, 3s is kind of appealing. Like, and also like it's worth noting I've got sort of like all of this nonsense happening. Is there some way to batch these arrows together that tells me the minimum is even more between if I count 3 arrows at once? Maybe that's what I'm doing, but it doesn't. So like naively, these 3 arrows sum to a minimum, if I do what I did before, of 15 plus 6 is 21. Can I possibly exceed that? I don't think so. Okay, if these two numbers do add to 15, then these two numbers also add to 15 for whatever that's worth. That's the problem. Okay, that's a problem. I have a hard time imagining that this is the intended observation. I think I'm probably being a bit dense here. But this digit can't be 6, because if this digit is 6, it makes that digit 9, which then means these add to 30. So now these add to 15. However, that means there's 7, 8. And now I need to put a digit that's consecutive to 7 or 8 on an arrow that I've just hypothesized sums to 6, which definitely does not happen. So in fact, this is an 8 with a 4, like that. Now, the question is, can I do exactly the same thing if either of these is 6? And the answer is yes. If either of these is 6, the other is 9, and now these are 7, 8. Oh, no, it's that one being 6 that doesn't work. This one specifically. This one being 6 would be okay, because this one could be 9, and then I could have a digit consecutive with 7, 8 on an arrow summing to 9, and that's probably fine. But that definitely can't be 6 for the same reason. And this can't be 6 for the same reason, and that can't be 6 for the same reason. Really does feel like we're trying to do some sort of like nonsense fish thing. Okay, this white dot has either a 2 or a 6 on it, which doesn't bode well for it being useful. It's funny, these are either a 1, 2 or a 2, 3 exactly. So there's always a 2 on them, which actually tells me what this white does. That's so weird. Just because the only way to make 7 is 1, 2, 4. So they would be 1, 2. If this is a 9, though, there's only one way to make 9 that uses a 4, which is this 2, 3, 4. So there's always a 2 here. And so this white dot now can't use 2, 4, or 8. So it must use 6 because every white dot has an even digit on it. And therefore, this is from 5, 6, 7 only. Now, this digit I know is not a 6 because I know there's a 2 here. Because I know there's not a 2 here. And so that digit is a 6. So there's no 6s there, no 6 there. That can't be a 5 anymore. But now this is a 1 or a 3, completing my trifecta here. And in fact, actually, sorry, now I've just got a 7, 9 pair. Right, now this is just a 7, 9 pair. And so if that's just a 7, 9 pair, which is probably the thing I was supposed to think about in the first place, then that's a 5, making that a 3, making these a 1, 2, which has made that a 7 and that a 9. I think I broke into this puzzle in completely not the intended way. Like, it's all worked out logically, and it wouldn't surprise me if it's one of those things where it turns out it's, like, in some weird way equivalent to the intended way. But it feels like I missed something. Okay, so there's no 8 here. So yeah, if this is going to be 6, that's going to be a 3 with these two being 1, 2 exactly. There's definitely a 1 and a 2. Oh no, there's definitely a 1 on this arrow is all I'm prepared to say. If this is an 8 and a 9, then those sum to 34, which would make that digit a 4. Doesn't seem like a problem. I was trying to see if there was some like weird combination that was going to be a problem. Oh, I see the combination that's going to be a problem. All right. The combination that's going to be a problem is if this is a 6, then that's a 9. And now these two add to 15. So that's an 8, but that's a problem because there's a 7, 8 pair up here. So this is not a 6. These are an 8, 9 pair, which means this is a 4 because of that math. And so now this is a 3 or a 5. Okay. There certainly is an 8 over here for what it's worth. There's certainly a 4 over there. We definitely need a 6 on one of these arrows, and either way it'll work out fine. This arrow always has a 1 and a 2 on it, I guess. Because I'm not putting a 1 or a 2 here. Okay, this arrow I see looks at this cell labeled 1, 2, which means it's not a 6 or a 7, because 6 would have to be 1, 2, 3, and 7 would have to be 1, 2, 4, both of which would destroy any possibility of this cell having a value. So in fact, we have an 8, 9 pair in the box, and now this digit, which has to be consecutive with 8 or 9, but isn't 8 or 9, just has to be 7, which makes that an 8, which makes that a 9, which makes that an 8, and makes that an 8 over there as well. Makes that a 7, 9, 7. Okay, well, we can't do 6 and 7. Those don't add to at least 15, so we do 8 and 7. Okay, and so now if we look at this, in fact, that has to be a 6, because in this column, these cells add to 30, so that's a 6, which then comes over and makes that a 9. This has got to be a 5, because it can't be a 7, making that a 2. Boy, there's lots of things happening. Okay, this is a 1, 3, 4, 8 arrow, because it can't be 1, 2, 5, and there's only 2 ways to make 8 and 3. If you do enough of these arrow puzzles, you learn the ways to make 7, 8, and 9, and 3. But for 8, it's only 1, 2, 5, and 1, 3, 4. And this one can't be 1, 2, 5. So it's 1, 3, 4. Which makes that a 2 and that a 1. Let's see. Okay, in this row, these add to 32. So these add to 13, which makes that a 5. So this is a 4 or 6. So 4 would go to 3. 6 would go to 7. Meaning that's a 1 or a 3. That's kind of bizarre. But what can you do? Okay, this is 1, 3, 4 for sure, though. Let's go ahead and write that. That's not a 3. Okay. It's a 1, 3, 4, but the 3's up here. So this is not a 3, it's a 7, which is what I kind of thought was going to happen because it sorts out those arrows. And I was imagining, why are we having these arrows at all? That's why. So now this isn't 1, 3, 4 because of that. This is 1, 2, 5. This is a very lovely puzzle. Although I probably would have put this one notch more difficult than the category that it is in, at least if you're meant to think about it in the way I'm thinking about it. If you're not meant to think about it in the way that I'm thinking about it now, then it's kind of amazing. These are 2, 3, 4, We know that one's not, oops, sorry. That one's not a 2. Let me not screw up the thing because of the 2-5 pair. Funnily enough, this is a 3-4 for the row. So that's a 3-4 pair for the box if you want. Not a 1, also a 3-4 pair for the column. Okay, this 9 arrow does not have a 5 on it, so it's not 1, 3, 5. So this has either got to be 2, 3, 4, in which case that would be the 2, or 1, 2, 6. In which case, who knows? Very similar to this 9 arrow over down here. Okay, this is a 2, 3, 4 as well. Okay, this 9 arrow, actually, I can say isn't a 2, 3, 4 anymore because it looks at a 2, 3, 4 arrow. So this is either a 1, 2, 6 or a 1, 3, 5. Either way, it's got a 1 on it, and that 1 is up here somewhere. Yeah, one of these two is 4. What is down here? 1, 2, 3, 4, 5. These are 6, 8, and 9. That one's not an 8 at the very least. So that is a 2, 3, 4. These are from 1, 2, 3, 4, and they don't include a 3. Owing to that. Okay, that is a 7 by Sudoku. Let's do Sudoku. This is often a good idea in these sorts of puzzles, I am told. Okay, so one of these is a 7. It's either that or that. And now if that were the 7, it would make this a 9. So this is only a 7 or a 9 because of the fact that there's a 1 in the column. So that is what I'm using there. Okay, so the 8 is over here. Because I'm not putting an 8 on this arrow regardless of what happens. So the 8 ends up over here, which rules 8 out of that and places the 8 there. Okay, if this was a 7, it would have to be 7 with a 2, 5, because we've got this 3, 4 pair and this 1 in the column. Let's see, is there something wrong with this being 8, 1, 9? I don't think there's anything immediately wrong with this being 8, 1, 9. What about 9s? What do I know about 9s? They go somewhere, huh? That's what I know about 9s. Very helpful, very helpful. Okay. Yeah, 6 is either going on this, which would be huge, or it's not going on that, which would also be huge. I know this isn't 2, 3, 4, so it definitely has a 1 on it, but that I don't think is helpful. Yeah, I guess I should probably fill out that these are also 1, 2, 3, 4. Just so that I can note that within this column, I've got a 1, 2, 3, 4 quadruple with the 3 living here and not there. And so these are 5, 8, 9 exactly. That was not an 8. Okay, so that does tell me, okay, that is actually useful. The 3 business was inexplicably actually useful. This is a weird sort of circumvent, or it feels like I'm cheating by doing this, but no, it's fine. It's fine. See, I'm not cheating. The 3 here ruled 3 out of here, which then through this 1, 2, 3, 4 quadruple forced my 3 to be in these cells and not here. And so now this 9 arrow is now looking down at a 1, 2, so it can't be 1, 2, 6, and it also can't be 1, 3, 5. So that actually tells me that this 9 arrow is 2, 3, 4 exactly. And if we believe that, then we know even the order it goes in. Which is all quite bizarre. But what can you do? Okay, so that's a 3-4 pair in the row. That's a 1. I guess it's a 3-4 pair in the box as well. This is a known digit of some sort. Could I have just added this column and gotten the same deduction? I might have been able to just add this, do math in this column and gotten the same deduction as I did through the convoluted method that I did. Though, for to be clear, it's the kind of convoluted method that I enjoy. This is a 6. Because it's sort of like incremental like use of and tracing where certain digits are appearing. Let's see. I know one of these two is a 5. Is that helpful? Oh, I know what this digit is. That's probably more helpful. How long have I known what digit this is? Has it been forever? It might have been forever. Anyway, this is not 1, 2, 3, 4. So 6, 7, 8, or 9. So this is a 5. Okay, which actually makes that a 3, which makes that a 5 and a 2. That's a 3-4 pair, making that the 1 for the arrow. We've got a 2 and a 5 up here, a 4 over here, 3, 4, 3, 4, 2, 3, 4, 3, 4. Okay, this is now not 1, 3, 5, or 2, 3, 4. So this is now 1, 2, 6. So that's the 6. These are the 1, 2, and we know the order thanks to Sudoku. 2, 3, 4. Okay, so that's a 5. Okay, let's see. We probably can fill in this digit. It's probably a 6, given that it's supposed to add to 9. Let's see. These are 2, 3, 9, I want to say. It's on a 2. That one's on a 3. Now the 7 can't go here anymore. It's a very Zeta step. I guess there's an easier way to do it, which is that there's a 5 on this arrow. But the way I saw it, the way that I saw it is if this is a 7, we previously said this would be 7, 2, 9, and that would break that cell. So that's not the 7. That's the 7. But we could also just say there's a 5 on it by Sudoku, so it's not that. And so it's 5 and 2, 9, 8, 5, 9, making that the 8, the 1, and the 9. Like that. Okay, so now we've just got to fill in the stragglers. Let's see. One of these is a 3, and it's that one. One of them's a 4, and it's that one. One of them's a 6, and it's that one. Let's see. One of these is a 6. One's a 7. And one's a 9. There we go. Very nice. I'm very curious to hear if I slightly thought about the break-in differently than the setters, or if you solved this puzzle and you thought about the break-in slightly differently, because the everything, like, once I got immediately past this and started getting into the like, well, adding what these can be and using it to calculate these sums, everything felt like, okay, I must be on exactly the intended path. But I felt like the step of, oh, this would need to be too big and it would break the 6 arrow, that part felt like I probably did that in not the optimal way. So let me know if you found a different way of thinking about that. It's possible it's like the same thing, but you can phrase it slightly differently so that it feels better, or maybe it was exactly that, but I kind of suspect there's something else. But anyway, huge thank you to everyone for watching this video. I hope you enjoyed it. Do please leave a comment, like the video, subscribe if you haven't yet, and stay tuned because there'll be more Invitation to Puzzles real soon. Thanks for watching. Bye for now.